Today I'm going to introduce you to a new number. This number is called E. The letter E is used because of the person who invented it. His last name began with the letter E. But the number E is a number that occurs in nature quite a bit, and it's kind of like the number pi. Pi is 3.14, but the number E has a role in many exponential applications that are done. And if you wanted to find out what actually the value of E is, there are two places on the calculator. E is actually equal to 2.71828. This is not a number that you have to remember, because on the calculator, and I would like you to grab either a graphing calculator or a regular scientific calculator also will have this this number E on it. If you hit second divided by, you'll see the letter, a lowercase e, come up. E is equal to that number. There's also another place where you can find E. It is on second ln button, which is beside the number 4 button. And a lot of times when we do applications that have the number E in it, E gets raised to some kind of a power. So if we want to take e to the first power, e to the first is still equal to e. So there are two places to find e. It's either on second ln or second divided by, depending on whether you want to raise it to a power or whether you just want to use the plain number e. Now there's an example number 2, this is on page 13 of your notes, that just asks you to calculate some numbers that involve the number e. So it says find to the nearest hundredth 1 plus e squared. Well, e has an exponent on it, so I'll use the second ln button. Second ln, 1 plus e squared. So that value is 8.389 with some other decimals. So to the nearest hundredth, it would be 8.39. Now here's some examples to do on your own. So what I'd like you to do is shut off the video right now, grab your own graphing calculator, and solve for x to the nearest thousandth, which means in example number 1, you're just going to take your calculator out and you're going to put e cubed plus 8, and that's going to give you a value. So go through examples 1, 2, and 3 solving these for x. And when you get done, you can turn the video back on and I'll explain how to find these. Number 1, e cubed plus 8. E cubed plus 8 on the calculator is 20.0855. To the nearest thousandth, that's 3 decimal places. So you look at the 4th decimal place, which is a 5, and the 5 rounds this 5 up to a 6. So 28.086 would be the answer to this one. Number 2, you're going to divide both sides by 2. And if you wanted to just put that in your calculator like this, you can, or you can divide -8 by 2, which is -4 e squared. -4 e squared is -29.556, and the 2 keeps the 6 a 6. And then the last one, x e to the 5th equals e to the 4th. Well, you can divide both sides by e to the 5th. So x is equal to e to the 4th divided by e to the 5th, which you can put it in your calculator using your fraction button. You can do this a number of different ways. E to the 4th divided by e to the 5th is 0.3678. Well, the 8 rounds the 7 up to an 8, so 0.368. Another way you could do it is you could subtract exponents, and you could call this 4 minus 5 is -1. E to the -1 would be the same answer. That's just a second way to get that same answer. Or you could call this 1 over e to the 1st, because e to the -1 comes down to the denominator. So if you wanted to do 1 divided by e to the first power. You'd still get that same answer. So there's just three different ways to get that same answer. We talked about compound interest in yesterday's video, and if you remember the formula, oh no we didn't, sorry. When you deposit money in a bank account, when did we do that? We did that a couple days ago. Yeah, we did yesterday. When you deposit money in a bank account, most banks compound interest more than once a year. Well, the example that we did in the earlier video was the banks were compounding interest just one time each year. But many times banks will compound interest or give you interest monthly or weekly or daily or just some different number than just once a year. So when this is a case, the amount of money that you'll have after a certain amount of time is given by this formula here, which is a formula that you don't have to memorize. I'll give it to you if it ever appears on a test or a quiz. But what you have to know is what are the numbers that you plug in to this formula. Well, the A value, just like before, is the amount of money that you're going to have in the end or after a certain amount of time. The P value is the initial amount, which is called the principal. That's the amount that you have in the beginning. The rate of interest is R as a decimal. Now, N is the number of times per year that the interest is compounded. So if you have something like compounded quarterly, N would be 4 because quarterly means 4 times a year. If you have interest compounded monthly, N would be equal to 12 because monthly means once per month and there are 12 months in a year. If interest is compounded weekly, the N value would be 52 because there are 52 weeks in a year. Sometimes it's compounded daily, so N is equal to 365 because there are 365 days per year. So the N value would change depending on how many times per year interest is given to you. And the letter T is time in years. So for example, Joan has $500. She's investing it in a bank that offers 3% compounded quarterly, where quarterly means N is equal to 4. The interest rate is 3%, so R would be equal to 0.03. If she invested $500, 500 is the beginning, the initial amount of money, so P is equal to 500. Let's just write some of these down. The interest rate is 3%, 0.03. N is quarterly, N equals 4. And we want to find out how much she's going to have at the end of 15 years. So that's the amount of time. Time is 15. So we have all of the letters on the right-hand side of the equation that we can substitute in. So the amount of money that she's going to have is P, which is 500, times 1 plus, R is the interest rate, 3%, 0.03 over N is 4. And you're going to raise that to the power of N times T, which is 4 times 15. And this is a calculator question. So we have 500 parentheses 1 plus, I'll use my fraction bar, 0.03 over 4. Close up the parentheses and raise it to the power of 4 times 15. Now, if you have an older calculator, you don't have a graphing calculator that will raise it up to the power like this, you're going to have to put parentheses around the 4 and after the 15, 4 times 15. But our graphing calculator will handle it. So after 15 years, you'll have $782.84. And that's the end of that problem. Sometimes banks will offer interest without interruption, which means the banks will give you interest every nanosecond of every day without interruption, which means N is kind of like infinity. an infinite number of times it will give you interest. This is called compounded continuously. So there's another formula that's simpler to use if the interest is compounded continuously. And it goes like this: A is equal to P, just like before. Now this E is the number E we just were introduced to, the 2.7 number, which comes out of the calculator. And R is the rate of interest, and T is time, just like before. So the only new thing here is the number E, the 2.7 from the calculator. So Tamika has $500, just like Joan did before, offering 3%, but this time it's compounded continuously. So now we're going to use the new formula. A equals P e to the RT. A lot of people call that PERT because that's what it spells. Find the amount of investment at the end of 15 years. So everything is the same as before. P is 500, but we don't have an end value anymore because it's continuously. So the rate of interest is 0.03 and the time is 15 years. So the amount of money Tamika will have after 15 years is 500 times e to the power of RT, which is 0.03 times 15. So again, this is a calculator question, and let's see if Tamika has more money. So 500 second ln e to the 0.03 times 15. And again, if you don't have a calculator that will have the exponent go up in this kind of a position, you have to open up parentheses before the 0.03 and close it up after the 15. So Tamika will have a little bit more money if it's compounded continuously. It looks like she'll have a little bit more than $1 more. So she will have $784 and rounded 16 cents. And that's it. Nice short video. Tomorrow we'll get some practice with our calculators using E and using some of the formulas.